time. We'll get started in about 5 minutes to give everyone a chance to join and settle in. In the meantime, I'm curious where everyone is joining from. Please share your name and location in chat. This also helps me verify that chat is working in case you have any questions during the webinar. I'm going to go ahead and post some housekeeping items real quick. This first thing in chat here is going to be troubleshooting steps that you can take if you're having audio or video issues during our session. Refreshing the browser, exiting and re-entering the webinar, joining from a Chrome incognito window, or closing any programs you're not using to free up resources. You'll also find a link to the slides that we'll be using today. So go ahead and follow that and bring those up. I'm also going to post a survey link. It's not mandatory, but it does help us get enough feedback to make sure that we're continuing to provide quality content. And I'm also going to post a few polls. These will basically, let's see here, not that one. So this is just going to give me some information about how you guys heard of us, what brought you to the webinar today, and let's see here. Go ahead and add those and then publish them. And this will kind of give me some information about how best to tailor the webinar. And again, those aren't mandatory, but they do help out. So my name is Mark, and I'm a data science consultant based in Phoenix. I've worked in industries such as real estate, AI security, politics, and I'm actually looking to get into the telecoms industry as well. I primarily just work with smaller businesses and organizations to help them leverage the data that they have inside of their organization to solve some problems, make things more efficient, automate things, stuff like that. So we got a couple more minutes, still waiting for a few people to join. We got about 16 so far. For those of you joining, just a primer, the first thing in the chat is some troubleshooting advice and a link to today's slides. We're going to get started here in another couple minutes or so. So why don't you guys tell me a little bit about yourselves? What interested you specifically in this talk, or in data science in general. And during the webinar, if you have any questions or anything like that, feel free to post those in the questions tab. It's going to be right next to the chat. I'll be monitoring that throughout the webinar. So if you do have any questions or you have any comments in the chat, I highly encourage you to post those so that I can address those and make sure that you're getting the best chance to get what you're looking for out of the webinar. All right, I'll get started in about another 30 seconds or so. For anyone just joining us, please follow the slide link in the chat. And if you're having any issues, go ahead and read those steps. And if you're still having issues, feel free to let me know. All right. So we're about 5 after. We'll go ahead and get started. Tonight's workshop is Intro to Data Science, the Art of Visualizations. You can find a link to that here. And this will give you a copy of the slides that you can take with you so you can study them later. You'll also find a link in here to the code that we're using. We're going to be using a Google hosted IDE called Colab that's based on Jupyter notebooks. And what that will allow you to do is have a dedicated separate environment. You don't have to install anything. You don't have to download anything. You just run this in your browser and it gives you a pretty sophisticated sandbox to play around with Python and learn and try things and make mistakes. So you'll see a link to that in here as well. And then you will also get an email link of this webinar once it's finished. A couple minutes after we're done and the live webinar has stopped, you will get a replay a few minutes after that. And then if you can't stick around for that, you'll get an email with a link to a copy of the webinar you can download. So all the materials we're going through here today, you will have access to later to study as you see fit. So again, a little bit about me. My name is Mark. I'm a data science consultant based out of Phoenix. What brought me here today is spreading these skills and this knowledge to as many people as are interested, because it's a very, very powerful set of tools and solves a lot of problems that we experience in society as far as how we manage all of this data that we're collecting. My programming experience is 8 years in Python. I've dabbled with JavaScript, HTML, and CSS here and there throughout those 8 years. Oftentimes, as a data scientist, you need to collect data, and part of that is web scraping. So knowing those three skills, even just to like, you know, an introductory cursory level, is a very useful thing to have as a data scientist. So yeah, a little bit about Thinkful. For those of you not familiar with us, we're a school who train web developers, data analysts, data scientists, and product designers. Our biggest two methods of providing that education are one-on-one mentorship and project-based learning. So every student gets a mentor that they work with to get guidance from. They're experts in their field. They can give you advice about the field and help you work through the curriculum. And the other aspect of that is the project-based learning. This is huge for Thinkful because, you know, this is accelerated learning. By the end of this, we want you to be able to go out in the market and demonstrate that you know these skills. So having a GitHub with 6 to 7 projects of things that you've built from scratch to demonstrate that learning is essentially, you know, how, you know, the credentials are that you're going to need to go out there and get a job. So that aspect of it is also very important for Thinkful because they have a guarantee that you will land a job within 6 months of graduation, or you'll get a full refund of your entire tuition. So we'll leave a little room at the end to answer any questions you have about Thinkful or our programs. But for now, we'll go ahead and get started with our workshop. Welcome, Mo and Bukala. If I mispronounced anyone's name incorrectly, please forgive me. And Greg, welcome as well. So this is an overview of the workshop. These are some of the things we're going to cover, and you'll get in a little more detail. So we're going to talk about the need for data scientists and, you know, why there's this rush in the market for people with data science skills. We're going to discuss some visualization principles. So these are more kind of aesthetics theory. And some suggestions and tips on how you can provide solid visualizations for the people that you have to communicate your findings with, and relevant packages in Python. So these are going to be libraries and things that we're going to use to access these tools. And then we'll do some interactive coding. Again, you will be able to keep a copy of your code. You'll be able to play around with it later. You'll be able to get more copies of it if you want to try different things. So we'll get started with why data science is a thing. So there's more data available now than ever before, but you know, it's kind of hard to imagine how much information we're dealing with. There's some statistics here, and I actually just looked up this you know, more updated version of the statistics, and this tends to hold true since about 2013 to today. 90% of the world's data has been created in the last 2 years alone. So when IBM published this, it was from 2011 to 2013. I've, you know, kind of checked this again, and there's a source as recent as April of 2018 that's saying that, you know, we've, you know, in the past 2 years, so from 2016 to 2018, we've collected, again, 90% of the data that exists. So Google on average processes more than 40,000 searches per second. This was Forbes, May of 18. Another source I looked at, May of 2019, is a little closer to 60,000 searches per second. And every minute, and this is according to Forbes, May of 2018, Users watch a little over 4 million YouTube videos, send 16 million text messages. There's almost 1 million Tinder swipes, and Venmo processes 51,800 peer-to-peer transactions. And this is every minute. So this is kind of where data scientists come in, and the data science set of skills. So they take all this information. So not, they're actually looking at, the 51,000 plus transactions per minute. They're looking at the 60,000 Google searches per minute. They're seeing granularly what this data is, and they're turning this into value for the companies that they work for, the clients that they have. So the specific steps in that process are data wrangling. So this is kind of what you're doing to process your data, clean it up. Some people consider, actually identifying what sources of data and going out and gathering that data, engineering that. Part of data wrangling gets a little more into data engineering. You have the analytics aspect of things. So this is kind of, where you're spending a lot of time with the data. You've had it pre-processed, it's all ready to go, and you've identified some models that you're going to start running this data through, and then you get to see the outcome of those models, and you get to explore that. And then ultimately, we want to be making some predictions. So this is kind of like the value part of the process. This is why companies are interested in data scientists and their skill set and what they can do. They can do very powerful things with data, like make predictions about maybe some future state, or even make a prediction about a previous state with limited information. So kind of like a, forensic reconstruction. How likely is this to be accurate, right? You can almost think of this as like latent fingerprints. There's enough data in a fingerprint that allows us to uniquely identify something pretty reliably, such that the analysis of that information leads us to a prediction of some past event that, yes, this person was here, they interacted with these objects, and we can derive fact from that. So data science basically takes that process and just amplifies it with computers. Some other common tasks are things like making classifications. So given some information, is there a pattern that we can uniquely identify? So in the finance industry, you could think of this as maybe like analyzing transaction data to detect anomalies in behavior like fraud. So again, this is a similar process we're doing in data science. We're just amplifying it with computers. So visualizations specifically are important in that they answer questions about the data. So you are going to do a lot of visualizations for yourselves while you're doing the analytics phase, while you're exploring the data and looking through it, and for others. And this is for kind of presenting your work and your findings, and communicating the complexity of the information you've looked at down to something that's digestible for someone who hasn't looked through all that data, who doesn't have the statistics and computer science background that a data scientist does to understand that data. And that's essentially what you're doing, is you're taking a large amount of information, you're looking for the most important parts of that information, and you're distilling that down and then visually communicating it to whoever is asking the question, the stakeholder, the CEO, a client, whoever it is in the organization. So now we're going to talk about some decisions in design, and this is kind of the theory of aesthetics I referred to earlier. So this is a GIF that's going to loop, and I'll kind of talk through some of it. So one of the things you notice is in the before image, there was a lot of extra information, right? You kind of have that chipboard background, you have shading, and you have shadows, and all kinds of redundant labels, extra information, a ton of extra lines for borders, 3D effects, multiple colors, all these things here are extra information, right? And information takes energy to process for anything living, and apparently anything not, right? Informations take energy to run and handle information. And so when you're looking at all this information, the visual parts of your brain have to process all this, right? And if these are things that don't really have anything to do with your point, the value that's related to what you've gone and found, it's just going to take a lot more effort for the people you're communicating with to try and understand that data. So a good rule of thumb, and this is kind of where it gets more into art than science. because these are aesthetic decisions. You know, you can quantify a lot of this stuff. You can go out and do a lot of cognitive research, but at the end of the day, you know, you're a human being. You're looking at that and you can identify, yeah, this is busy and this is really easy to understand. I can find the information that I'm looking for in a quick, simple fashion, and there's not a whole lot else that's going on. And you want to aim for that. You really want to try and limit the amount of information you're presenting to the overall point of what you're trying to make. And that will allow your audience to focus on what your point is and quickly understand the value that you're trying to demonstrate for them based on the analysis that you've done. So here's an opportunity for you guys to participate. Any suggestions? I'll give you guys about 30 seconds to just look at this chart and study it. And then I want you guys to give me some pros and cons of just the visualizations of this chart. You know, how easy is it to understand what's going on? Are there any conclusions you can make from it? Is there anything that makes it confusing? Stuff like that. So I'll give you guys about 30 seconds to do that starting now. So go ahead and study it and make your suggestions. About 15 seconds left. I already see some suggestions. Thank you guys much. About 5 seconds. All right. Okay, let's see what you guys put. Let's see here. So Greg suggests the text is too small. I definitely agree with that, especially because you have things at different scales. So scaling is an important thing to consider with graphs, but you may not want to scale texts that have similar values, right? Because now it's difficult to read that. And if you want to represent like a value ratio, probably not smart to do it through text. So that's a great suggestion. I agree. Also, the color scheme is very confusing. Like, do these colors mean something specific? If they're there and they're supposed to mean something specific, maybe we should have a key or something that tells us what these mean. You can also slightly see there's like this pattern in here. You know, I'm not quite sure what that means either. Alana suggests it looks like fossil fuels and renewable energy represent two halves. Yeah, absolutely. So it's like, you know, it's hard to understand what they're trying to say, because now if my attention with all this busyness going on here does not, you know, I miss this information here, I might just look at this and assume that, you know, fossil fuels and renewable energy are, you know, the same size in the economy or receive the same number of federal subsidies. And, you know, that's very misleading. And, you know, when it comes to matters of policy and things like that, you know, like let's say you see this chart on your favorite cable news outlet, and you know, this could influence how you vote on things or influence what politicians you support. So it could have very real consequences. So most suggest dropping the sections in the core as they're insignificant. Yeah, you know, I mean, if information is so small that you can barely read it, I mean, you really have to wonder if you need to change the scale of things or if that's even information worth having. Alana also suggests 72.5 billion gets the same space as 29 billion. Yeah, exactly. You know, as humans, we kind of automatically look at the different sizes of things to give us information about the properties of those things. And again, you know, there's kind of a statistical hazard going on here, almost kind of like an optical illusion that might lead people to the incorrect conclusion. And you raise a good point with that. So Greg says 72.5 billion versus 29 billion. Obviously, a big oil lobbyist created this slide. You know, and that touches on something that's very, very deep and very important with statistics. It's very easy to lie with statistics, either intentionally or unintentionally, right? So, you know, you have to be very cautious about how you allow your data to be visualized, so that you're drawing the correct conclusions, so that you're representing the information that you've analyzed with as high a fidelity as you can. So yeah, that was great. So we'll do this exercise a couple more times here. So same thing, I'll give you guys about 30 seconds to take a look at this and kind of analyze all the information here and tell me what you like about it, what you don't like about it. And I'll go ahead and start that now. About 15 seconds left. All right. All right. So we got a couple suggestions. Alana says you put a little more white space between the rows. So yeah, so I'm assuming you're referring to kind of right here. And this creates a couple of issues as well, right? So you've got, this information is very close together. This almost looks like it could be a continuous graph. It's just got a lot of noise in it, right? So it's almost like the white space hurts you more than it helps you. It'd almost be better to either squish these together or separate them even more. And of course, you run into the problem of squishing them together where the labels are now going to be really hard to read. So increasing the white space would definitely be the better decision, and maybe even upscaling these a little bit. You also run into an additional problem, and this is kind of the argument of making this a continuous, block of area rather than having white spaces. These are like continuous values, right? You're going through percentages, and the problem with this is you can see that these percentages aren't even lined up with their values. So it might even be better to like reconsider the scale of this, increase the white space, or get rid of the white space entirely and just make these sufficiently wide enough that you can match the text. And then, just there's so many different ways you could represent this data differently that it'd be so much clearer. Greg says, there's a lot of words, but the visuals provide key information. Yeah, so, kind of going back to the same point that these are just really tiny and you have all of this white space available to represent this idea. It's not very balanced. So, it's kind of like you have main information here. So these are the movies where men have 60% or more of the lines. And then you have, the gender balance ones, so that are, within plus or minus 10%. And then you have, women having the 60% of the lines. Right. There's just so many different ways you could visually represent this that would make that a lot clearer. Magdalena says the visuals are informative, just a lot of text in a small space. Yeah, exactly. So kind of making better use of the white space out here, maybe finding a different way to represent this graphically so that, it's easier to comprehend and you're using your white space more reasonably. And then Alana also adds, but in this case, the imbalance makes the point of the visuals really clear, in my opinion. Yeah, potentially. And again, I agree that it does make the point very clear. But if you were to find a similar way to make the point as clear, but also give yourself substantial more use of the available white space, you can fix a lot of the smaller structural issues that kind of make this difficult to interpret, because it's almost like an information density problem, right? If I only have a limited amount of important data on a slide, but I put it all the way up in one corner and make you have to analyze a higher density of that, it's going to make it really difficult to, because now your brain is automatically cutting out all the white space, but now it's spread out over a larger distance and can be more difficult to interpret. And that's why balance is very important, because balance is what's going to give you kind of, a uniform informational, process where your attention can go from one thing to another thing to another thing. And it's kind of evenly distributed over the space that the information is presented in. Mo suggests that the data is too finely grained, so it's too granular. And then Greg says, I'm perceiving the left column to be more important than the center and the right, but that is the exact opposite goal of the slide. Yeah, and that's another thing to consider too, is, two people could look at the same graph and interpret different conclusions. Someone might look at this and say, okay, the important information is isolated out here, and so you have a lot of room to pay attention to it. Or someone else could look at this and say, oh yeah, this is where most of the information is. This is what's important. So that's another reason why balance is significant, right? Because you you don't want to accidentally divide an audience on some parameter that you aren't even aware of or don't even understand. When you give balanced information, you're kind of forcing people to look through all of the information rather than drawing their attention to one place or another. And you will need to draw their attention to specific places, but you want to try and make it so that that path converges as closely to the same for everybody. You want to take, you know, someone's attention from one place to the next place to the next place, and really only need to do that if there's kind of like a chronological order of steps that's required for them to interpret that data. Otherwise, if it's just like, you know, bam, here's some information, you want that to be really balanced, and you kind of want their attention to just kind of naturally be controlled over what information they need in what order. So, you know, there's a lot of subtle details that you can get into as far as aesthetics goes. And you know, it's something you really have to be considerate of when you're trying to convey information. This chart to me illustrates a really important aspect of having empathy for your audience, because they don't, you know, oftentimes they're not going to have a mathematical background, or they're not going to have use of these tools, or they're not going to have looked at all of the data that you have, where your brain is just primed for information related to that data set, but they haven't had that benefit. So I'll give you guys about 30 seconds, and starting a couple seconds here, to kind of go through this chart, try to understand it, think about what you like, think about what you don't like, think about how you could improve it, starting now. About 15 seconds left. About 5 seconds left. All right. Bukola says, I'm just staring at the screen, can't hear anything. Okay, let me see if I can help him real quick, or her. Okay. All right. Let's see here. So Alana says, too much 3D. I try to flatten it into stacked bars. Yeah, I definitely agree with that. And, you know, this kind of, again, speaks to the idea is that you really kind of want to increase the impact of the information you're presenting by presenting things as minimally, to your point, as possible. This also kind of runs afoul of, you know, again, I'm a data scientist. I've looked at the data. I've gone through, I've analyzed it all. My brain has been highly exposed to it. So I might be able to look at this. I personally haven't looked at this data set. I have no idea what this graph means, but, you know, if I were the data scientist involved in this, I could probably look at this and tell you everything about this chart and all kinds of conclusions, and it'd make perfect sense to me. But then I go and I try to present this to someone in marketing or in product design or to, you know, C-level people, and they haven't looked at that data, and they're going to be like, yeah, this is very noisy. You know, so this is where I would say it'd be appropriate to maybe take one of these one slice at a time and make it its own slide, and then step through the quarter and say, okay, this is quarter one, this is quarter two, this is quarter three, this is quarter four. And then what's the important thing about showing this data? Are we showing a comparison for growth? Are we saying, actually, I think this is medical data or something like that. But, you know, what's important about this is the fact that these are trending upwards, and, you know, it's so busy, it's hard to know what's going on. And then, yeah, so Omar suggests maybe changing what you're visualizing this as a pie chart. And that would go towards, you know, maybe you do need to just walk people through the raw summary data and say, like, oh yeah, okay, so this is quarter one, quarter two, quarter three, and quarter four, and then have a summary slide, you know, that's additional to this, maybe a fifth slide that uses different visualizations to show different things that are important about this collection of data here. So yeah, great participation. Thank you guys very much. So I think this is, yeah, we've got one more here. So same kind of thing. Go through this one, take about 30 seconds to look at it, analyze it, and tell me what you like about it. Tell me what you don't like about it. We'll do that starting now. All right, got about 5 more seconds. All right. All right, so we got some suggestion here. Greg suggests it's a very clean graph. Yeah, and I would agree with that. Aesthetically, this is very easy to look at. As kind of in terms of controlling attention, you can see that, everything else is grayscale, and then the two important lines are, right here. They're very easy to notice. They're almost the first thing your eye goes to when you're looking at it. So if it's important for someone to understand that there's a trend here, and that's the first thing that they see on the graph, this is very well done. Alana recommends not enough context. What does the y-axis signify? Yeah, so let's try and figure that out. So dunks are up everywhere. Number of total dunks attempted, or number of total dunk attempts and dunks made in men's Division I college basketball between 2009 to 2010 season and the 2018 to 2019 season. Okay, so yeah, which one is which? So this total dunk attempts, total dunks. So yeah, it looks like the number that people have tried versus the number that were successful. So there's some ratio here, and this ratio actually seems to stay pretty consistent. I mean, it kind of widens up here and then narrows back down here. And then you can see kind of it starts to maybe look like it just might start wanting to widen. So what does that mean? So obviously if any one of these X values is a number, then the number of attempts and the number of successes is going to show you the ratio of success. So the higher this line is to this line, so closer they are together, the higher the success ratio. The further they are apart, the lower the success ratio. And then you can also determine that, okay, so these are the y-axis looks to be the total number of of dunk attempts, or I guess attempts or successes, or however you want to frame it. And yeah, I agree. It very much limits the context of how to interpret this. Look at how much cognitive processing power we had to go through to just tease out the assumptions that we needed to make to determine what the value of this is. It'd be much better to have something that's, clearly labeled, clearly defined. What things are. Maybe add some key values here that kind of show like this is what you're supposed to be interpreting from this graph, other than just that there's a trend in, people are trying to attempt more dunks and they're getting more dunks successfully. So yeah, and this is kind of one of the, you can kind of consider this to be like, oh yeah, I've looked at the data and this is all the information that you need. It's kind of to the other extreme of, here's too much data and I expect you all to understand it. It's like, oh yeah, okay, here's the minimal data you need to understand this, but because I have more context than you, this is easy for me to understand and not so easy for you to understand. And this is a failure in that kind of empathy that you would need. So this provides too little information about context for sure. And you could fix that by maybe labeling some of these things. Let's see here. Omar agrees with Alana. Simple title, clear subheading of what is being displayed, says Greg. Yeah, again, we were very easy to, determine what these things meant just by doing a little bit of reading. And Ashok agrees that it looks simple and clear. And Mo says needs some watermark to show what's an acceptable level or not. Yeah, so is there criteria for how many dunks that need to be attempted, in any game, or where's they kind of provide a source here as well. But yeah, having some kind of anchor points would be very useful. So I think the top line is the total number of attempts, and then the bottom line is the total number of successful dunks. And Greg says not having thousands on the y-axis is confusing. Yeah, so you just kind of get this K. This is the only piece of information that you have to make it clear what these are. So again, I would say that this suffers from oversimplification of the information you're trying to present. So yeah, great suggestions, and I really appreciate the participation. So now we're going to start getting into more what Python is, what programming is, why it's such a useful thing for data science, and there's a ton of things that Python can do. It's kind of for a long time been kind of like a jack of all trades, master of none. You can do web development in Python, but if it was very hard to go find someone that was going to pay you to know Django, right? A lot of this was just kind of more hobbyist and intro to web development stuff. And there are companies that use Django and things like that, but for the most part, web development is going to be JavaScript and some form of JavaScript stack. Robotics, it's definitely capable of doing it, and there's a lot of useful things you can do in Python with robotics. But a lot of people, they're going to be using C or something that you would use to program an Arduino, for example. So it's definitely has use in that, but and automation and things like that kind of goes in with the robotics in the physical sense, and then automation of tasks and movement of information in the software sense. But it's really recently found its niche in data science. I attribute this to kind of all these big data companies, Google, Facebook, Amazon. They kind of went to academia and hired all these people with these extremely deep science and math backgrounds, who kind of learned how to code over time because it was useful, and then they had them start building a lot of great tools, and a lot of those people then turned around and developed some amazing open source projects that were all based in Python, because they were Python is very much used in academia because it's very simple and easy to learn, and still yet very powerful. And so now you basically have these cutting edge data science tools that are largely being written in Python, and the implications for the accessibility of these tools is now very, very significant. It's very easy to spend a little bit of time in learning these tools and how to use them. And you'll see how very simple it is, and that's why I see that it's kind of grown with and kept up with the pace of the growth of data science, and even arguably driven it a little bit. So Omar asks, robotics such as corporations like DJI. So here's one of just a quick side note on abstraction, right? And kind of like low-level languages versus high-level languages. So you can use Python for robotics. A lot of it is like hobby robotics or rapid prototyping type of thing. And that's what Python is really great at, is if you have complicated ideas that you want to get out quickly and just have something run, Python is where it's at. But Python's a very high-level language, and what that means is it takes a lot of computational resources to do what it does and make it easy. And when you're looking at a company like DJI, they're going to most likely be dealing with what's called embedded programming, and so they identify their hardware, kind of like your cell phone, right? Samsung or Apple goes out and they say, okay, we know how to make and design phones, and we know what parts we need, so we're going to go out and buy a CPU that's as small and efficient as possible. And we're going to buy some RAM that's as small and efficient as possible. We're going to put all this stuff together, and then we're going to write very, very, very low-level code to manage how those components work together and communicate and move information around. And then we're going to sell that as a premium, and people will use it, and then they'll install higher and higher level software on it to make it actually useful, type of thing. And in Apple's case, they do that. In Samsung's case, they rely on Android, which is an open source version of or an open source mobile operating system made by Google. And so when you're dealing with robotics, especially for things like drones, you need a lot of precision, and it needs to be able to adjust very, very quickly. So you probably would not see Python running on anything that DJI is manufacturing. However, there are people who've like jailbroken their DJI drones, and they'll use Python to now control that drone remotely. So all of the stabilization, all that stuff that's still going on is going on at a very low level on the chips, and then you have kind of higher level software that's going to be closer to the human and interfacing with the information from the human. And you kind of have this full stack of abstraction that goes into controlling something like that. So just a little side note on that kind of stuff, and kind of where Python fits and how, what kind of circumstances it'll be useful in. And the way I kind of think of it is, if anyone knows anything about 3D manufacturing or like manufacturing objects, you've got like 3D printing, which is really useful for making a lot of interesting, complicated, iterative ideas, right? Kind of rapid prototyping. But once you have a design, once you're committed to a design, 3D printing kind of falls short with, kind of reliability and stability and what you can do with it and things like that. So maybe you have a really good idea that you've 3D printed. The next step is injection molding, right? And the problems with injection molding is it takes a lot of upfront costs. You have to commit to a design. If there's any mistakes or problems, it's a mess. Basically you have to remake the mold. But once you have that, you can pump them out thousands a second, and they'll be way, way closer. The tolerances will be much, much tighter. So I kind of see Python as more of like the 3D printing side of that analogy, where it's like, if you want to explore complicated ideas very quickly and just get feedback, and Python is really great for that. If you want something that's going to be like, it's going to take a lot of work to get going, but once it's dialed in, it's going to be very fast. That's where you want to look at something like C or Rust, or maybe even if it's low enough level, maybe assembly. So yeah, just some information on where Python fits kind of in the computer science engineering turf. So now we'll get into some packages. So tonight we're going to be looking at a couple packages. The first one will be Matplotlib. This is a 2D plotting library. It makes easy things easy and hard things possible. And it has things like plots, histograms, power spectra, bar charts, error charts, scatter plots. We're going to look at a few of these tonight, but the kinds of visualizations are vast. And I encourage you to look at Matplotlib's documentation to find more information about that. And you can see this is kind of what it outputs, right? It's you get all these different kinds of visualizations that can be very, very complicated or very simple. So it's very, very powerful. The next visualization package we'll look at is Seaborn. So this is a data visualization library based on Matplotlib. So it kind of uses Matplotlib as its foundation, but the syntax, the code that you actually use to produce these graphs, is a little different. It's a little more optimized with the purpose of data visualization in mind. So it makes a lot of tasks in data visualization much easier to do than Matplotlib. So you can almost kind of think of it as like a data visualization wrapper on Matplotlib that's its own standalone library called Seaborn. So it's a very high level interface for drawing attractive and information statistical graphics. It's closely integrated with Pandas data structures. We'll get into a little more of what that is. Pandas is another library we're going to be using in our data science stack. And then a dataset-oriented API for examining relationships between multiple variables. So it's kind of one of the things that Seaborn offers. And then convenient views onto the overall structure of complex data sets. And just kind of like how I mentioned that you have low-level and high-level programming. This is kind of the same thing. So Seaborn is a little more abstract than Matplotlib. And the reason why is because Seaborn relies on Matplotlib. So the reasons why you'd want to use Seaborn is if you're trying to make a graph that you have very fine-tuned control over from an aesthetic perspective, and it's very easy to code and program that. So maybe it's things that you have to generate a lot of different variations on and things like that. Using Seaborn will make it a lot easier to do that, but it will have a performance cost. It will take a little longer to do things in Seaborn than it does in Matplotlib, and that will tend to scale with the more data that you're trying to analyze. You'll kind of see that Seaborn takes much longer than Matplotlib for larger data sets. But the reason why you use it is because it's going to give you a lot easier control. So you kind of have to balance whether it's appropriate to use Matplotlib or whether it's appropriate to use Seaborn. And, my suggestions for that is, use Matplotlib when it's kind of like quick and dirty. Like you're just trying to understand something. You're exploring, use Matplotlib to do things as quickly as you can, just to see the information. You always want to label things appropriately and things like that, but you kind of think of it as like, kind of like a painter going through multiple different sketches of things until they feel like they've just got it right, and then they start playing around with the color and they iterate through that until they just have it right. It's the same kind of concept here. You want to visualize your data, you want to explore it. The more of it that you see, the more lenses that you look at it through, the more the value will kind of avail itself to you. So you're going to be doing that a lot. You're going to be creating a lot of visualizations in your analytics phase. And so you want to use something that's a little quicker to just get the information out, because you can take advantage of the fact that you've kind of poured your mind through that data set, and you can take for granted that you understand it. And then invest the time into turning that into a proper visualization with something like Seaborn, and then finally control that for when you're going to present that to someone. Alana, thank you for posting that. So this is going to be the link to the Colab that we'll be using tonight. So like I mentioned before, you won't have to download or install anything to follow along. This is kind of a self-hosted, a self-contained Google-hosted version of Jupyter Notebooks. And we'll go over how to use that. But for now, you'll go ahead and click on the link there, or follow it from the chat. It's going to open up a new version, or it's going to open up kind of this the version that's at this link here. And so this is a version that you cannot edit, but this is kind of like our hard copy, or our original copy, I guess, if you will. So what we're going to do to get you guys your own copy is we're going to click on File. It's up here by the Colab logo in the upper left-hand corner. You'll click on File, and you'll click Save a Copy in Drive. We'll wait for this to load. And so, hold on here, full screen that. So now you'll have your own copy of this. You can see that you can edit this. Just to demonstrate that, I'll go ahead and do, hello world as a string. We'll store it in the value X. So we have our string assigned to the value of X, and then we're going to print X. And just make sure that this is working, and it is. So we know we can edit it. We know we can run code. Just a couple of quick things about Colab. You have code blocks, you have text blocks. You won't really need to add any, as we're going through this. But like I mentioned, you'll have access to all the materials related to this webinar, the copy of the webinar itself, the copy of the Colab Notebook, and the slides. So I highly encourage you to, take some additional time, go through this, explore it, see what causes errors, see if you can fix them. Just kind of use this as a resource to get a lot of experience. Maybe see if you can find another data set and pipe this in here and see if you can make that work as well. And if you run into an error, you can't fix it, you can always go back to the original link. You can always file and save a copy in Drive, and now you're starting from scratch. So I highly encourage you to kind of go through this, make errors, and get as far with it as you can. So the kind of the idea of data science is, you want to ask a question. You want to say, given some information, what can we interpret from this? Or maybe you don't have data and you have a question. You have a CEO or a client coming to you and saying, if I had the answer to this question, I could do something better. I could make something better. I could make something faster or more efficient. So the question we're going to ask here is, what makes buying a home in California so expensive? And to do that, oops, there we go. And to do that, we're going to go through this code, and we have our data. All this code here looks pretty complicated. I won't spend a lot of time going through it, but it's basically grabbing I'm going to go ahead and close this copy here just so I have this up. So it's grabbing the data that's at this link here. Kind of open that up so you can see. And you can see that there's some folders in here, that it goes to GitHub. It belongs to an account called Agaron, and he has a lot of useful machine learning data sets on his GitHub. We're going into housing, as you can see here, and then we're going to the .tgz file, and this is a tar file. This is a compression. This is almost kind of like a zip or a rar. But it's an open source standard. It's used heavily in Linux. It's very, very efficient. And basically what it outputs is this CSV. So we kind of do this I guess you could say we took the scenic route for this data to kind of demonstrate what you can do in Python to show you different ways of how to handle different kinds of files. So of course, if you wanted to just grab the CSV, it's much, much easier to do that. But now you have the code. So when you're kind of playing around with this stuff on your own, if you run across this kind of file type, you have some code on how to handle it. And some of the significant aspects of this are, if you wanted to change where this points to, you would just change the URL. And then, if there's any kind of directory involved to get to the file, you would change these. And then it's going to check if a path exists. It's just a real quick thing about Colab. So this is actually, a Linux version. So if you click here, sorry, there's a little bit of delay. If you click here, you can see that there's a whole bunch of like directories and things like that. So if you're used to Windows, you would consider this to be like your C drive. And then inside of that, we have the content folder, which we started in. We have the sample data here. And you can see that we have a lot of this information in here already. But this code is going to be here for you to use kind of on your own. So if we run this, you can now see, if we refresh this, we have a folder called dataset now. And so that's kind of where we created this, datasets housing path. And then it created the dataset URL. It grabbed the housing /housing.tgz file, and it downloaded that into here. And you can now see that we have two files, because once we've run this, it downloaded the TGZ file with this code, and then it extracted it with this code. And that's why we have both of these files in here. And this is actually pretty cool. I encourage you to explore this as well. You can, mount your Google Drive to it and have access to, kind of whatever data you drag in from the internet to explore. And the way you access this is just with this little arrow key here, and in the upper left-hand corner. So we'll run that. So now we have our data set. We have a version of our data set that's going to be easy for us to read. And then we load that data into pandas. So the way that works is we have housing, and we set that equal to the function that we created up here. So fetch housing data, or I'm sorry, load housing data. And then we've given it the argument housing path equals housing path. And we've created a variable called CSV path. We've assigned that to the output of os.path.join housing path, and then the housing CSV that we extracted from the TGZ file we downloaded. And then we're returning a pandas data frame, so PD, which we've imported up here. So we have import pandas as PD. And this as is basically just an alias. So instead of having to type out pandas, we can just type out PD. And then we're running the read CSV method on the CSV path. So the CSV path variable is what's giving us the output from this. So this is actually taking the data in and then turning it into a data frame, and then it's returning that data frame to our variable housing. So anytime we refer to our housing data, we're going to know that the kind of data that it is a pandas data frame. And a pandas data frame is a data structure that the pandas library uses to keep track of information so that we can efficiently manipulate it and analyze it and things like that. So that's that code. The next couple of things we're gonna do is a couple of steps I highly recommend. Anytime you pull in a data set, you always want to understand and confirm the data that you're looking at. So if we go here and we click this, where's the raw? Oh, here it is. Yeah, view raw. Okay, so if you click on this view raw link here in GitHub, it's going to just give you basically a HTML rendered CSV version of this file. So CSV is comma separated values. So you have your header row here. These are all your attributes or columns. And you have your commas here, which are going to separate those values. And then you have every row is a list of values separated by comma that matches the order of what attribute it represents. So this is the longitude, this is the latitude, so on and so forth. So that's essentially how a CSV works. And when we run housing.head, so housing is a representation of this information in our pandas data frame, and we're going to run the head method, and we're going to pass the argument 5, the integer 5. So when we do that, you can see now that this information matches up with this information. And it gives you the first 5 because that's the integer that you passed through there. So I'm going to run this again without the 5, and you can see that you get the same information. A little confusing, but what's going on here is if you pass nothing to the head method on a pandas data frame, you will have an implicit value of 5. You can put more in there, and that will return more of that information, or you could put less in there. That's up to you. But if you put nothing, you will get the first 5 entries, and that's indexed starting from 0. So the next thing we're going to do is look at the shape attribute, and you can see that this uses parentheses and this doesn't. And the reason why is attributes are basically just metadata about the information. These are functions. Methods are essentially functions that allow you to pass an argument to it. And so you can do that with the head and the describe method. So there's many things that you can pass, many arguments, different kinds of arguments you can pass to the head and the describe methods. But they have some basic implicit values that you don't have to put something in there. Whereas the shape, this is just giving you geometric information about the data set. So it's going to tell you the rows by the number of columns. And just a quick point on jargon here. So because data science is kind of a interdisciplinary endeavor, it's kind of an intersection of computer science and statistics, applied mathematics, things like that. A lot of those domains have slightly different jargon to describe the same thing. So you kind of see a flood of a multitude of different ways of describing things in data science. And in my opinion, that can make it a little bit intimidating to learn. So I'm going to spare you guys some stuff. So columns, attributes, I'm now the third one escapes me, but columns, attributes, things like that. They're all referring to the same thing. You'll kind of learn that as you go and look things up, and you'll realize like, okay, yeah, these are basically describing the same thing. So just keep that in mind. And then finally, we're going to look at the housing.describe method. So I think we're a little further along here. Greg has a question. I'll go ahead and continue. I'll let you type that out, and then I'll address it at the end of this slide here. So we've looked at the shape, and we have our .describe method. So our .describe method is going to give us summary statistic values on the numerical attributes. That was the word I was trying to think of. So columns, so attributes. Let's see here. So the numerical attributes only. So these are the attributes that only have numbered information. You can see that ocean proximity is not present because this is a categorical label. It's basically a text label. Oh, okay, yeah, here you go. Let me know when you're ready. We'll work at the end, Greg. I want to make sure to answer your question, but I've got to, kind of have to proceed. Oh yeah, so looking at the type housing, yeah, so it's a pandas core data frame. So the type is basically a function, a Python function that you can use that will tell you the type of data. So like if we were to do a string, So, like our string X up here, if we were to do a type of that, it would tell us, oops, it'll tell us that that's an X. Or it'll tell us that X is a string. So you can do this with lists, you can do this with integers, you can do this with, so like if we pass the integer 5 here, it'll tell us that's an integer. So type is just basically a tool that you would use to confirm that some variable contains a data structure that you're expecting, or a data type that you're expecting. So let's see here. So the shape attribute and the describe attribute are all very useful things to use, as well as the head attribute. And basically what this is going to do is give you enough information about your data set to confirm that you're using the right one. Because a lot of times as a data scientist, you may end up dealing with many different types of, or many different sets of data, and you want to make sure that you're keeping those straight. A lot of times it could be very similar data, maybe the same data from different sources, stuff like that. So you always want to make sure that you do your due diligence and verify the information that you're looking at before you spend a lot of time and computational energy, analyzing the wrong data set. So you have your summary statistics here. So this is going to be your count, your mean, your standard deviation, your minimum and maximum, your quartiles. And the more you understand about statistics, the more valuable this gets. So I highly recommend, kind of learning some of the fundamentals of that if you aren't familiar. But we'll just kind of go over a quick couple things because we're coming up on time here. So like one easy thing you can interpret from this is that, just by looking at the count, you can see all these all these attributes have the same value except the total bedrooms. And you can see like, okay, I'm going to have to make some decisions about null values or missing. You have to make decisions about missing data, basically. So you have to decide how you're going to do that. Can you drop it? Just drop all the rows for those empty values. Can you fill them in with maybe like a median or something like that? So yeah, you kind of have to figure out what you want to do with stuff like that. But running the summary statistics on it can give you a lot of key insights about how you're going to pre-process your data and what kind of things you're going to want to do to start cleaning it up. So we're going to do a little bit of live coding. And this is where you're going to, anywhere you see these triple asterisks with the capital letters, this is where you're going to put your code in. And what we're going to do is import the appropriate packages that we're going to use. So this is the code here. I'll give you guys about, say 20 seconds to kind of type that in where it says revise this line of code starting now. About 10 seconds remaining. And then if you don't quite get it in that 20 seconds, you'll see me kind of type it on up here. So we have this here. So this is where those lines of code will go. Let me grab those so I can copy and paste it, just so I don't make any errors. There we go. Okay, so I'll go through this code kind of line by line. So the first thing you'll notice is that this is kind of grayed out, and there's a hashtag in front of it. If we take that out, we notice it changes to white. This is how you comment things in Python. So commenting your code is highly recommended, especially if you're going into this as a profession and you're going to be sharing your code with other people. There's certain things you do as a matter of courtesy that makes your code readable. There's certain conventions you follow that make it kind of quick and easy for everyone to interpret code. Commenting is a big part of that. If you're interested in more of that, check out the style guide PEP 8. If you remind me towards the end, I can link it to you a little later, but if you Google that, it'll bring you to the documentation for PEP 8. And familiarize yourself with those conventions. It will make you a better programmer, and it will make your coworkers like you a lot more because it makes their jobs easier. So commenting is important. So what we're going to do here is import the appropriate packages. So we're importing matplotlib.pyplot. And as mentioned before, we're going to use an alias here, and the alias we're going to use is PLT. Not only does this save you a little bit of time and keystrokes, which, little bit of time it saves you, but this is more for a readability convention. Kind of like what we mentioned before with the PEP8. One of those conventions is an 80 character limit. Colab gives you a reminder of that. So when you start running long on things, it'll kind of say, hey, you're kind of breaking a convention here. So PLT, instead of taking up all these characters in a line, you can just kind of abstract it down into something simple. It makes it easier to deal with those readability conventions and keeping that 80 character line width. Next, we're going to import Seaborn as SNS. Same kind of thing here. So now instead of having to type all this out, we just type PLT and SNS and we have access to those things. So then we're going to set the default style to consider colorblind readers. So we have PLT, which refers to our matplotlib.pyplot, .style.use, and then we're going to pass the use method a string that is defined by single quotes and is going to match something in the Seaborn library that tells it to set a color scheme. And that label is basically Seaborn-colorblind. So go ahead and run that. And you shouldn't get any errors. You shouldn't get any output. All we're doing is importing these things into the namespace just to make that a little less abstract. This is kind of, what's going on with that. So this is the, all the things that have, value in the namespace currently. So you can see we have, fetch housing data, get our housing, which is our pandas variable, load housing data. So these two things are the functions that we defined. We have OS because we imported an OS model, PD for pandas, PLT for Matplotlib, SNS. All these things are kind of in your namespace, and you get things into your namespace from Python by importing them, and then you can give them aliases to simplify things. So that's the directory command or the dir command. If you want to know what variables are assigned, you can get that information from running this this command here. Next, we're gonna kind of look at some of the data. Going back to our big question, what makes houses in California so expensive? We kind of want to start asking some questions. So let's find out what the distribution of the median house value is. So that's a reasonable sub question of trying to figure out why they're so expensive. Is let's just look at how expensive they are. The semicolon here is going to suppress the visualization object report, kind of show you guys what that is when we have this coded out. So I'll give you guys another 20 seconds. So this is the code that you're going to be replacing. So create a histogram of the median house values below. So where it says revise this line with code, you're going to place, oops. You're going to place that, you're going to place this at that location. So I'll go ahead and give you 20 seconds starting now. All right, about 5 seconds. Okay, so this is the code that you'll have wanted to replace. So PLT, again, this is referring to our matplotlib.pyplot.hist. So this is the histogram method. So that's kind of the first part of this. So we're creating a histogram, and we're creating a histogram of the median house values. So the median house values is going to be an attribute or a column of our housing data set. So we basically want to select this data set and select this column of values. And so the way that we do that is by using square bracket notation on our pandas variable. So our housing represents a pandas data frame of our housing data. And then we use our square brackets here. Whoops. We use our square brackets to start and finish. And then what we do is we pass a string between those square brackets or a list if you want to select multiple values. We pass a string of the name that matches the label or the attribute that we want to select. So we have matplotlib, histogram, and then our median house value. So we'll go ahead and do that. And you can see that we've kind of we've got some labels, or we've got some values on the labels for the X and Y axis, and you can kind of see that there's a distribution here. But and I know that I mentioned earlier that, we don't, these are kind of quick and dirty for your own understanding type of thing. But you definitely want to make sure you're still labeling things. And that's just as much for you as anything, because it can be very easy, like I mentioned, where you want to kind of double check, with the head and the shape, and describe methods and attributes that you're confirming what data you're working on. You kind of want to do the same thing with your labels. You always want to title things. You always want to label things, because when you look at this visualization, it's not going to be like a cognitive illusion where you think you're looking at one data set and interpret it, think it's something else, and that might mislead your analysis. So having the title and the label, or the X and Y labels, is as easy as just doing, you create your histogram, and then you create a title, an X label, and a Y label for it. And I'll leave it up to you, kind of given our request up here. So create a histogram of median house values below. For those of you not familiar with a histogram, it basically shows the value counts of items in a data set. So it's going to look at all the home values, all the median home values in this area. And just a little context about this data set. So, as we do the analysis, you might see some weird things related to house values. But another thing to keep in mind is where the data came from. And in this case, the data came from the Census Bureau, from, I believe, the 1990 census. And this isn't at the resolution of a per household basis. This is information about the block. So their data point is basically blocks of homes, and then they have information about each of those. So like, if we have obviously the longitude and the latitude, we have the housing median age. The reason why they're using a median here is because they gathered a bunch of information about the number of homes in that block, and then took the median age of all of those homes, what year they were built and what year it was currently when they gathered the data, and they took the median age. The total number of rooms is basically the total number of rooms in each of the houses in that block. The total number of bedrooms, same thing. The population of so the number of people that lived in that block, the total number of households in that block. So this was looking at 126 households with a total of 880 rooms, a total of 129 bedrooms, and a population of 322 people. And then the median income median income and median house value, and the proximity of that block to the ocean. So think of it in terms of that, and that kind of speaks to the importance of doing proper data wrangling and understanding where the data came from, how it was collected, maybe even why it was generated. Understanding why could fill you in on some kind of incentive blind spots that will be helpful for you to account for and provide proper analysis. So you always want to make sure you're labeling your data. And so we're going to create a histogram of median house values below. So we want to look at the value counts of basically the distribution and frequency of each cost point, right? So with that in mind, we want to provide a title, an X label, and a Y label. So I'll leave you guys about 30 seconds to do that, and you'll have that in this slide here. Okay, so we're going to title it distribution of median house values, and the X label will be the median house value, and the Y label will be the number of houses, so the value count of the histogram. So I'll give you about 30 seconds starting now to go ahead and fill that in. About 15 seconds. All right. If you're not finished yet, don't worry. You'll still be able to get it here. So first we're going to create our plot just like we did above, plt.hist housing median house values. And then our title will be distribution of median house values, or the title will be distribution of median house values. The X label will be median house values, and the Y label will be number of houses. We'll go ahead and run that. And now you can see that we have our title and our labels. So adding that information is just as easy as this. And I highly recommend that you do this, even for just graphs for yourself, because it's always going to give you the minimal context that you need to understand what data you're looking at. And then the other thing too is it can help you catch mistakes. Let's say you did make an error previously, and now you're looking at this and be like, wait a second, this doesn't make sense. You know, that can clue you into, like, you might need to go back and look at some more data and kind of make sure that, you know, you've done everything properly. But in this case, it does make sense. So, you know, we kind of know we've taken confirmation steps along the way to make sure that we're dealing with the correct data, and we've labeled things properly, and we've matched that up with, you know, the information that we've provided to Python. And so what we see here is, you know, there are very, very, very few homes under kind of the $50,000 range. And, you know, then as you get closer to 100,000, it spikes up and then peaks out about 150. Now, keep in mind, this is data from the 90s. So, you know, obviously homes in California are quite a bit more than this these days. But so it kind of spikes up and then comes out and around and then levels off as you get higher and higher and higher. And then you see this spike at 500,000. Part of this is, again, knowing the data that you're dealing with. So there's a decision made by the Census Bureau to just, you know, cut off the higher and higher value homes because they just got rarer and rarer, and it was difficult to, you know, keep track of all that information. So they just said anything that's 500,000 and up, you're just gonna, you know, cap it off at this, and that's how the data is represented. So that's why you see this uptick here, because realistically, this distribution would kind of continue to slope down and slope down and slope down until eventually, you know, you reach the max value of real estate or of a house in California. But then that's only one value, and that's going to taper off all the way over here and do all sorts of things to the scale. So that's, you know, you can kind of think of everything up here, you know, from kind of this value and above. This is the sum of all the actual values that were distributed. And again, this kind of looks like an illusion, right? It'd be very easy to say, oh, hey, you know, everything goes down and then bam, all these homes. And that may still, you know, be the case, but it's useful to know about what data you're dealing with so that you can look at something like an anomaly like this and be like, oh, okay, yeah, this is still following a pretty reasonable distribution, and there's just an artifact of how the data was represented that's causing this. So we kind of covered how to kind of run, you know, your own graphs for your own analytical purposes. Next, so we're going to take a look at where are the houses located in regards to ocean proximity. So if you kind of notice what we're doing here is we're starting with some value, some attribute that we've been given, in this case, the median house value, because that seems to be the one that's most related to, you know, the easiest to quantify attribute as far as our question goes. And the question was, why are homes in California so expensive? So we've kind of looked at this attribute and said, okay, you know, we kind of have an idea of the distribution. Now let's start looking at these other attributes and see what's hiding in this data. So next we're going to look at the ocean proximity and see if, you know, look at the data and see if that has any relationship to the value at all. So is this live coding? So this one's not live coding. Or wait, yes, it is. Okay, so so we're generating the values we are using for the following plot. So we have housing ocean proximity dot value counts. So if you just run this, it's just going to give you text data, and that's okay for now because we're dealing with categorical data. But this is going to give you what your categories are. So instead of having to, you know, the kind of time the time that this saves you is, oops, if I can get, there we go, is, you know, let me do like 25 values. Oops. I think that'll still run. Yeah. So, you know, instead of having to look through all this, I mean, these all say near bay, you know, and actually a better indicator would be, there we go. So instead of having to scroll through all this data and look for like, oh, you know, what are the unique categories? As you can see, I mean, I can scroll, now I can page down, and, you know, now I'm starting to see less than an hour from the ocean. Okay, that's another label, inland. It takes a lot of time to do stuff like that, especially when you're dealing with many more values than what we're dealing with here, which is only 20,000 values. You know, some of the data sets you're going to be dealing with as a data scientist could be in the range of, millions or hundreds of millions, and you can't just scroll through all that. So what the value counts output is going to do for you, a couple things is, one, it's going to kind of give you enough data to produce your distribution that we did with the histogram. But two, when you're dealing with categorical data, it's going to tell you what your categories are. It's going to tell you everything that has a unique value and then how many times that shows up. So that's just as easy as running housing, which again is referring to our pandas data frame that has our housing data, passing the ocean proximity string, which matches the attribute of that column of data, and then running the value counts method on it. And that's kind of what we passed into this. That's kind of what the histogram does, is it does a value count and then it shows you a graphic representation to it. And then this is what we're passing in as the value. So this is a different way syntactically of doing this to just get the raw data. But the value counts function the value counts method is a function of pandas. So you can run this on any item that is of that type, the pandas data frame. So it provides this text out for us. So next we want to look at a bar chart. So this is also useful for bar charts. So bar chart for those values are going to be here. So we're going to look at our ocean proximity, we take our value counts, and then we're going to do a plot. And the plot method is going to take an argument, kind, and that's going to tell us what kind of bar chart what kind of chart that we want to look at. And in this case, it'll be a bar chart. And then we're going to give it a title and an X label and a Y label. So this will be what we're creating, and then this will be the code that you'll type out. So I'll give you about 30 seconds starting now. Let's go ahead and type that out. About 15 seconds. All right. Okay, so here's the code, if you still need a little bit of time typing it. So I'll just kind of go through this real quick. We have our number of houses by ocean proximity appearing as our title, which matches this string here. We have our number of houses, which matches our Y label here. And then we have our ocean proximity, which represents our categorical data, which is appearing as the X label, which matches here. So just kind of looking at this now, we can see, okay, there's a lot of homes that are less than an hour from the ocean, which makes sense. People want to kind of live near the beach, maybe not, if not right next to it, at least, maybe within a reasonable drive of it. And then you have a second kind of chunk of data that is inland, so the further away you get from the beach, there's just fewer and fewer homes. And then these are the ones that are near the ocean. So maybe like right on a beach, or, I'm sure there's some decision they made as far as cutting it off in terms of distance. And then these are the number of homes near a bay. So you can imagine like San Francisco or something like that. And then these are the number of homes that are on an island. So like a very statistically insignificant number of homes are on islands. Let's see here. So next we're going to look at how does ocean proximity relate to the house values, right? So we're kind of going through the same process that we did with this, is like, okay, we're just kind of we're subdividing the big question into smaller questions. And then, small questions that we can give to Python to get information back about the data. So in this case, we're looking at the distribution of house values. In this case, we're looking at the number of houses by ocean. Now we want to try to figure out how does ocean proximity relate to the house value. So what we're going to use is group by to do that. And I believe this is live coding as well. Yep. So we're going to generate the values for the following plot using group by. So we've got our housing, and then we're using our group by method, and we're passing it the ocean proximity. And then we're selecting the median house value as a string. we're going to take the mean of that, then we're going to sort the values by descending. So ascending is the attribute, or the parameter rather, and the ascending parameter of the sort values method allows you to pass a Boolean, true or false, and it can't be lowercase. This is case sensitive, so you have to have a capital F. You can see that between this and this, we lose the syntax highlighting. So you want to make sure that when you pass this, you pass it as a reserved keyword Boolean in Python that your syntax highlighting will tell you. If we pass true, of course, it'll be ascending, and false will be descending. So go ahead and run this. And now you can see we've kind of grouped the information, the categories in the ocean proximity based on the median house values in that category. And then we've sorted those values descending. So we've gone from the largest value to the smallest value. So the homes near the island, the median house value is 380,000 plus. The median house value for homes near the bay is 259,000. Near the ocean is 249,000. Less than an hour is 240,000, and inland is 124,000. So kind of the further away you get, obviously, you're living big if you're on an island, and then things kind of go down from there. You can see the bay seems to be a little more valuable than near the ocean, but not a whole lot. And then as you get to further and further away, it goes further and further down. So now we're going to plot a visualization that represents this. And we're going to do that with this code down here. I know you can't see right now because of this bar, but go ahead and drag this away, and you should be able to see that now. So I'll give you about 30 seconds starting now to fill that in. About 10 seconds left. All right. So go ahead and bring that code back. So this is the code that you should have. I'll leave this up here for a little while if you still haven't gotten it typed from the slides. And then I'll go ahead and run this. All right. So we have our average median house value by ocean proximity. So we have our title here, and that kind of tells us what's going on. And then we have our average median house value on the y-axis and our ocean proximity on the x-axis. So of course, as usual, that all matches up to where that goes. And now we can we kind of have this sorted. So we can kind of see that given all the data statistically, it's near the bay, near the ocean, less than an hour in the ocean, makes it's not a huge difference. But if you want to live on an island, you're going to pay a lot. If you're okay living inland, you're not going to pay as much. And that kind of does follow our intuition of what we would suspect, home values to do. We kind of have a natural intuition, and sometimes it's like, well, why even go through all this to just confirm what we know? The important thing is that it's one thing to have an intuition about something. It's another thing to have measured data on that thing, because you're now getting more information if you either confirm or kind of challenge your natural intuitions about things, because if this had showed up otherwise, now all of a sudden it's like we're very curious, and maybe we start by ruling things out like our own mistakes. Maybe we can't find any. We bring in a colleague and start doing that. And so when we find paradoxes and anomalies like that, we put a lot more attention into it. And in a way, when things are being confirmed, when your intuitions are being confirmed, and you've done things properly, that's a good sign that you're kind of on the right track to developing a way of modeling something, which is essentially necessary if you want to predict or classify things. So it's good to have your intuitions properly confirmed, and that kind of speaks to another reason why it's so important to understand the data that you're looking at, because like that anomaly here, you could be like, oh yeah, maybe this isn't about home values, maybe this is you're doing cancer research or something like that, and you don't quite understand the data you're looking at, and you see something like this and you're like, oh man, that's that could be really great. That can mean a lot of things. And now you're putting a lot of attention into something that you may have already known to expect if you'd spent the proper amount of time looking at your data and understanding where it came from and why it was generated and things like that. So all those things are going to inform you in terms of context as a data scientist. And it's a very important part of the process to go through. So let's see what we have next here. Okay, so now we have a challenge. So we're going to take a look at how's another continuous variable related to ocean proximity. So pick a different column and generate another group by bar chart with it. And don't forget to update any relevant labels. So I'll kind of break this down. What they're asking you to do here is, continuous is a little loose here, but basically what they mean by this is any other thing that has a float value. So any of these other attributes, median income, households, population, total bedrooms, all these, kind of like what we were talking about before, right? We looked at our we looked at our first attribute based on kind of like what was most related to the big question, and now we're exploring the other attributes to see how they're related. This is kind of your opportunity to do that and apply it now. So again, we're gonna use the group by and create another bar chart. So we're going to create another one of these. So already that tells you that you're going to be using a lot of similar syntax as this. You have a bar chart here, and then you have different things you can put in here, and then updating your label appropriately. So instead of looking at ocean proximity, I'm sorry, this isn't the one you want to update. You want to look at, let's see, to show different continuous variable. It's related to ocean proximity. Okay, yeah. So this is the variable you want to change here, and then this is the label that you'll want to update here. So go ahead and pick one of those other attributes if you want to get an idea of what those are. Go ahead and scroll up. Pretty much, I mean, you can see longitude and latitude. That might be interesting, but it's probably not going to tell you a whole lot. But any of these other ones might be very interesting to look at. So go ahead and select one of those and update that. I'll give you about say 30 seconds to do that. I'll go ahead and take this away so you can see the slides. And you can see the challenge laid out. And go ahead and start that now. About 15 seconds. All right. Anyone want to share their code and have me run it and kind of go through it? Go ahead and post that in chat. Give you guys a few more seconds to finish up. I know this stuff is new, so. All right, so I'll go ahead and create a new code block here. Put in. Okay, so I'll go ahead and copy Alana's code and paste that in here. This is, for you guys to know, this is just code that I copied from up here, just kind of show you where the changes are. She has a bar chart. Excellent. Ascending is going to be true, so she chose to look at the ascending start values, and she looked at the housing median age. And if you have any errors, I'll go through this code, and then we'll see what we need to do to get the get it working, and then I'll address any errors you have. I definitely encourage you to kind of read the error. That'll give you some information. Even if you don't quite understand it, definitely encourage you to read through it, and then we'll address it here in a second, and I'll have you post your error, and I'll troubleshoot it. So housing median age, and the title is median house value by median house age and ocean proximity and median house value. So we'll go ahead and run that. Okay, so lots going on here. So one of the things that happened is instead of changing this value, we're now instead of comparing ocean proximity to another continuous variable, we're comparing two continuous variables, and that's kind of why you got so much information, because now Matplotlib is comparing all the all the individual values between these things, and it kind of overloaded. So one of the things I can do to fix this is we're gonna cut this out and then paste it here, and then take that out, and then we'll copy ocean proximity from that and paste that here, and then median house value. So we went. So we want median house age. Oops. By ocean proximity. And that the reason why ocean proximity is the challenge asked for different continuous variable that's related to the ocean proximity. So that the way we're going to maintain that relationship is by keeping this the same. So our independent variable is going to stay the same, and then we're going to update what our dependent variable is. So we'll go ahead and run this. No, you're good. You're good. And you know, this isn't to kind of like put you on the spot or make you feel bad. This is, you know, this is complicated stuff. I mean, there's so much information you have to keep track of and go through, and you know, like I've made these mistakes a million times, and you're probably going to as well, and all your colleagues will as well. And what's important is that when you make mistakes, how to correct them, right? Because you know, when you ran that code, you probably saw a bunch of random data that was just like, oh wait, that wasn't what I was expecting. And you have to get used to feeling that feeling as a data scientist, because that's what's going to hone your intuition when you're looking at data and being like, something's not right. I must have done something wrong. And then, you know, just basically from there, it's just sharing my thought process of, you know, like almost as if I had made that mistake, what would I go through to try and fix it? And I think that's an important thing to share. And see, exactly like Greg says, you know, your mistake was helpful for him. You know, the fact that you're able to share that, now someone else who had made that mistake, they gain value by getting the answer because they may have had a similar problem. Let me see here. So Faith contributed some code as well. So go ahead and run that and see if we can. Okay, so housing group by ocean proximity, median income. All right, so she's looking at this one here. So instead of the house value, she's looking at the median income, which kind of looks like this, median income. And I'm curious why these are 8 dot. I'm going to bet that these are maybe in like tens of thousands. You know, again, this kind of comes to knowing your data set, but my best guess is that this value, the like 1.9167, would be 19,167 for the median income. So we'll go ahead and look at that. Scroll down if I can find it. Okay, so we're comparing the house. Oops, one more. We're comparing the ocean proximity and the median income. She's going to represent that descending. It's going to be as a bar chart, and then the title is going to be average median income by ocean proximity, and our X level is going to be ocean proximity, and our Y level is going to be average median income. So go ahead and run that. There you go. So it seems that there is some negative relationship between the average median income and the proximity to the ocean. Obviously, we kind of have, you know, one categorical data here that you know, you can see that even though this is a statistically insignificant category, when we're looking at our prior value, our prior housing median age, or housing median house value, it's much more significant here. And so kind of the intuition behind that is, you know, the average median income of someone who lives on an island is probably pretty high. But, you know, why are these? Oh yeah, so these are in tens of thousands. That's right. Yeah, and so, you know, again, it's kind of helpful to know your data, and this can get a little confusing. But there's some, you know, again, this is our intuition flashing here of, you know, like what's going on here that you know, this is lower than everything else. You would expect that you know, this would be higher, but you know, maybe people who live on islands have lots of kids and they don't work, and then they have, you know, that kind of like shifts it, you know, as an anomaly. And so again, like when this doesn't match your intuition, when you see a paradox like this is when you want to say, okay, I need more information. I need more data. You know, maybe we need to go find better data. Maybe this data set isn't appropriate for what we're trying to answer. and of course it isn't, and the reason why we use it is because it's very helpful from a learning perspective because it's easy to access and it's commonly circulated data. And it's very easy to demonstrate because it's not a lot of data with our limited resources, right? And so when you see anomalies like this should be kind of like a beacon of the map is not the territory. The thing that represents the actual thing is not the thing itself, right? And so you can start to see limitations in the data by simply analyzing and doing this level of analysis. And this kind of teases out where the real value in data science comes from, is you're now able to ask a computer questions in a language that it can understand and get information back about very, very complicated, very, very vast data sets. So yeah, let's see here. Faith says, right, this is very interesting to think about and brainstorm possible explanations. Yeah, so, and this is kind of my favorite part of being a data scientist, where it's kind of like a chess game with a computer. You want to know more and more and more and more, and you follow all these challenges all the way down, and you get used to having your intuition confirmed and intuition challenged in very interesting and unexpected ways. And it's given me the opportunity to learn about every field that I've operated in. Exactly. Yeah. They don't work because they don't have income. They just kind of live off of interest. So yeah. So next we're going to look at median income versus house value scatter. So, and to the point of further exploring the data, sometimes it's just a bad visualization. Maybe something went weird, and you want to kind of look at it through another lens. So what we'll do is I'll have you guys. We haven't really covered scatter plots, but I'll give you a hint. So in kind, where you want to put that is instead of bar, you want to put scatter, and then it's going to be very similar otherwise. So I'll give you guys about 30. I'll give you guys a minute to kind of think about that one, because that one can be a little tricky. We haven't covered scatter plots yet, but I think you guys are getting this. And actually, this would be a good time to add another poll. So what I'm going to do is, where is it at? Okay, I'm gonna add this poll here real quick. Again, you don't have to fill it out, but it will kind of help me make sure that I'm explaining things to the best of everyone's understanding. So the question is, where did it go? Oh, here it is. How well you are understanding the topic. So go ahead and take about 15 seconds to fill that out, and then that'll kind of help me determine how deeply I need to explain things, or maybe I could speed things up for you a little bit if you're really grasping it. All right, so good. Okay, yeah, you guys are getting it pretty well. So I'll give you about a minute here in about a few seconds. Go ahead and think about how you would represent this data as a scatter plot, and then we'll see what we can do. Yeah, this one's going to be pretty challenging. You guys may need to Google search, but we'll go ahead and take a minute now, and we'll see where everyone gets. About 45 seconds. Thank you, Greg, for the documentation. And you're right. Yeah, they are different. I kind of I accidentally misled you guys with my statement of pointing you here. So ignore my hint, and check the documentation. About 30 seconds left. All right, about another 5 seconds left. Or sorry, 15 seconds. About 10 seconds now. Okay, anyone want to attempt and contribute and see if we can run your code? Give you guys a few seconds to decide. All right, no takers, and that's fair. This is I think I want to make a note about this one because this one's kind of hard. Actually, I wonder. You know what? Oh, you know what? That's why. Okay. Some of these are, so we had a challenge on one thing, and now we're kind of going back to the learning aspect of it. So sorry about that. I'll give you guys another 30 seconds to kind of type this out. Yeah, there was the technical issue. Okay, so I'll give you guys about 30 seconds starting now. About 15 seconds left. Okay, so I will bring the code back. And so this is what we have here. So we're referring to our Matplotlib library, so PLT, and then we're using the scatter method, and then we're going to pass our housing median income data as one argument, and our housing median house value data as a second argument. And then we're going to provide it an X label, so median income in tens of thousands, and median house value. So I'll go ahead and run that. And you can see, as the income increases in tens of thousands, the median house value also increases, and pretty quite sharp as well. And this again, so you kind of have this line here, and you have this line here, and you have this line here. You kind of have you see these bands forming. So these are most likely due to biases in how the data was collected. So I kind of went back into the idea of, we had this cap of 500,000 at the top, so all these values may have kind of been scattered about, and you can kind of see some interesting things, right? If you look at each of the extremes. So this person has like no income, but they're living in a very expensive house. And you kind of see that all the way across, right? Down here, you have someone, that has, a block that has a very high median income, but is very, has a very low house value, right? Maybe that could be like retirees. If they're getting pensions and Social Security and things like that, they could have a very high median income, but maybe they just stayed in the first house they bought, and type of thing, and it's just kind of like an older neighborhood with retirees, and so you can kind of see how very little amounts of information can start generating a lot of additional questions. What you might want to do is now look at this data point and get more information about it. What is its geography? What is the average age of people living there? All those things. Yeah, exactly. Thank you, Greg. Yeah, that's the term I was looking for. Long-time residents. And so as the house values grew around them, and as they started making more and more money, they just kind of stayed put. Maybe they have a really great neighborhood and all that. So you can kind of just look at the extremes of things and start to imagine, like, why is that there? Why that data? Why does that exist? And kind of just let the questions pour out of you, and document those things, and gather more information, and you'll be able to uncover some very interesting things about the data you have to look at. Someone had an error on the previous one. I can't remember who that was. Did you get that resolved, or did you want me to circle back on it? Just let me know in chat, and we'll kind of proceed, and if you still need help, I can revisit it. So let's see here. So we have our scatter plot. So now we have a second challenge. Okay, so this is kind of the learning, and now we're going to apply it. So the second challenge is, what's another relationship between two continuous variables, and generate another scatter plot to illustrate it. And don't forget to update your relevant variables. So that is going to go under challenge 2 here. Okay, hopefully you guys can hear me. Some issue, but I think I found a way around it. So let me reshare this. Okay, can you guys see my screen? Just give me a thumbs up if you can. All right, let's see here. I'm gonna go ahead and just close that. Okay, so excellent. Where were we? Okay, so yeah, hopefully you got a little bit of time to do that challenge while I was out sailing. Fortunately, I'm not in California. I'm in Phoenix, so still have power for now. And let's see here. So yeah, we're running a little short on time. We got about 6 minutes left, so we'll go ahead and run through this real quick. Let me see here. Okay, so challenge 2. Hopefully you guys had some time to try this out. Did anyone attempt it? Attempt the challenge while there were technical issues? Give me a thumbs up if you did. Okay, cool. That'll save us some time. So I'll go ahead and put the code back up here and go ahead and paste this in. Just because of the time limitations, we'll go ahead and just do one code block. So we'll borrow Greg's since he was first. I'll create a new code block here and run that. So we have a scatter plot. We're running it on our ocean proximity on our housing data against our median income. So ocean proximity versus median income. Everything's updated. Perfect. Oh, interesting. What did I miss? Use a scatter plot to show a different relationship between two continuous variables. Don't forget to replace any relevant labels. Oh, okay. So yeah, this is just any two variables. And so this is actually a really good sign. An indicator when you see stuff like this that you may consider doing something like a bar chart instead. We can kind of see. So we have ocean proximity with the median income. Hold on here. Interesting. Oh, okay. So you want to try and do another continuous variable. So let me grab something else here. Yeah, so what's going on there is because there's only so many categories, there's only like 5 or 6 categories. That's why you kind of see those really, really straight lines. Okay, perfect. I'll use the population one here. So let me scroll down and find that real quick. All right, run that. There we go. Okay, so you're taking population as independent and looking at the median income. So it kind of shows that there's some kind of positive relationship. It's hard to know if it's really sharp or if maybe there's a lot of anomalies in the data that we're looking at, but let's kind of explore it. So we kind of have the extremes here. So the block with the highest population, and remember these data points are blocks. So the block with the highest population had the lowest median income. So, I mean, that could probably suggest certain things about, poverty and like high density living. You had a lot of basically what this is telling you is where the lowest density of population is, you have a pretty wide range of median incomes. You're pretty much covering, so that people of every median income lives in low population areas. So you can kind of conceive of this as like maybe really, really low median income rural areas that has a low population density, and maybe like Beverly Hills where there's a house every 2 acres type of thing, and then every continuation in between. And then you kind of, as population increases, you kind of see that distribution kind of fade away until it reaches a cap, until you see some anomalies out here. And again, we don't know whether those anomalies are maybe due to the data that we collected, because again, these are just blocks. So we'd have to go look at more information to get that. And that's kind of how I would analyze this graph. So that was actually quite a good one, because even though it's not a familiar shape that you typically see, it still tells you a lot of information at the very minimum about the data that you're dealing with, and some additional clues of how you might remediate some of these problems. So next we're going to look at a correlation function. I'm going to do this quickly because you guys have the slides in the code. I'll encourage you to kind of go through those on your own pace. So the correlation is basically taking each one of your attributes and comparing it to each other attribute. So what you end up with is this is what's called a Pearson's correlation heat map, or a Pearson correlation. So you can see that the attributes where they intersect with themselves are going to be 100% similar, which makes sense because when you're looking at the median house value and the median house value, those are literally the same data, so they should be perfectly aligned. But then you also have a color map here where you go from dark blue to dark red, and the dark blue is more dissimilar, and the dark red is more similar. And so now you can see what are some really dissimilar attributes. You got total rooms and housing median age. So there's almost no correlation, and you see this negative 0.36. So it's kind of the darkest it goes is the latitude and the longitude, right? So like because this is like a nominal labeling of positions of Earth, the latitude and longitude just kind of have really nothing in common with each other. It's just a combination of those things that give you information. So that kind of makes sense. But then the dark red areas where you kind of look in the center here, where you compare something like total rooms and total bedrooms. That makes sense because the more total rooms a house has, maybe a house has a den and a living room, it tends to have a lot more total bedrooms. So this gives you a very quick way to see what are some of the related and unrelated values, so that you don't have to iteratively go through the process that we just went through. You can just kind of see where the interesting areas are. So this is kind of an additional abstract representation of the data. So we'll go ahead and, like I said, because we're a little limited on time here, I'm just going to go ahead and fill these in. You'll have all the code in the slides with this. So again, we're just basically creating plots. So in this case, we're creating a slightly transparent plot for each of the blocks as they appear based on their latitude and longitude, and we're representing that with a scatter plot. And now what you can see is this kind of familiar shape emerging, and it's the shape of California. And the reason why you want to use the transparency is because let's say we didn't use it, and we run this. Oops, that's not going to work. I just set this to 1. It's really hard to actually see where the population density is. You can kind of tell where it is, but you know, is this more dense than this? I don't know. So when you change that to a value like this, now you can kind of see a little finer detail. And then so changing the point size, so we can change the point size, and that's going to give us a little higher resolution image of where things are at. So we'll go here, changing our point size. I'll go ahead and run that. And you can see now the dots are a lot smaller and they're still transparent, so you can kind of see finer and finer detail of where the real population density is. And then I'll do this one as well. And so this is adding not only the alpha, but a size. So this is how we're making it small. The label, of course, is going to be there. The C is the median house value. The C map is going to be, this is the color map is set to jet, and then we're going to show the color bar true, similar to these other ones here. Let's go ahead and run this. What happened? I'm gonna run out of time here. Yes. Where though? Median house value and C. I see. Thank you. Good eye. All right. There we go. So now we've kind of added more color over the median house value. So what you see is the larger the median house value, the larger, or the redder it's going to be, the lower the median house value, the lower it's going to be. And now not only can you see the population density, but you can also see where the expensive areas are. And now you have this information. This essentially answers our big question. And yeah, I'm sitting here sweating like, oh, I'm on a time clock and now I got to find this error. So it's definitely harder to think when you're under pressure. Yeah. Kind of go, this is where you'll find the code for each of these. So just to go over some of the stuff we learned today, we kind of got a sense for, you know, why data science is in demand. We looked at some aesthetic theories and visualization principles. We looked at histograms, bar charts, heat maps, and scatter plots. And oops, hold on here. Okay, so yeah, let me give you an email address real quick. All right, and I'll be in chat. I'll hang out in chat after I end the webinar. So I'm going to go ahead and wrap this up real quick. Hopefully our time today has you feeling a little more excited and confident to continue learning data science. So if you have any questions about Thinkful or any of the materials we've covered, I'd love to get into those now. So as you're typing out your questions, I want to provide some additional information. So whether you're just getting started or have already picked up some foundational skills, you're going to want to keep this momentum going. And that's kind of where, you know, where you want to take advantage of as many opportunities to learn as you can. Meetups are great. YouTube tutorials are great. I use it for keeping up with a lot of research. There's a lot of active news that's being done in the field. Of course, any kind of coding website, so DataCamp is a good one. They have some very useful tutorials. You also have the Thinkful resources. So with Thinkful, you are, we have a 2-week free trial. And when you sign up for this trial, you gain access to about 100 hours of actual program curriculum. You get unlimited office hours access, so kind of similar to sessions like this webinar format. You get a lifetime access to our student Slack channel. So combining the webinars, so the kind of content we're offering here, and the trial is a really great way to learn because it's going to show you how to apply the things that you're learning in specific ways in data science and cover a lot more skills that we didn't have time to dig into today. So now I want to open the door for any of those questions. If you're interested in scheduling some time with an admissions advisor, you can do that here. I'll give you guys the link in chat. And then when you're ready to try out the 2-week trial, you can do that here. Again, our survey link is going to be found here, and I'll repost the slide link as well, so you guys kind of have that. And again, you'll get emailed a version of the webinar that you can download. Where is the slide link? Here we go. So here's the slides. And I'm going to go ahead and end the webinar. Like I said, I'm going to stick around for another maybe 10 or so minutes to answer any questions you have, if you had any errors come up or anything like that. And then ways you guys can connect with me if you have any further questions. So again, I really appreciate you guys showing up. I had a great time. I appreciate all your participation, and hopefully you found it useful. So thank you for joining.